Billions of years ago, when Earth was just a hot ball of rock in space, something incredible happened. Comets, these giant balls of ice and dust flying through space, started hitting our planet like rain. What seemed to be just random space rocks crashing into Earth might have actually been the most important delivery in the history of the universe. These icy visitors brought water, but not just that. Scientists discovered they also carried the basic ingredients of life, like space delivery trucks bringing everything life needed to begin. This forced scientists to ask a question that changes everything. What if we're not from here? What if every living thing on Earth, including you and me, are actually descendants of microscopic passengers that traveled billions of kilometers through empty space inside frozen comets? Subscribe to the channel, leave your like and comment from which part of the world you're watching, because now I'm going to tell you everything. Where did the first living thing come from? This question is simple, but the answers are not easy. A very long time ago, our world was empty and quiet. There were no people, no animals, no plants. There were not even small flowers or tiny bugs. The surface of our planet was only rocks and hard gray land. Sometimes fire would come from tall mountains that spit out smoke and hot lava. These were volcanoes, and they made the air thick and hard to breathe. The sky was not blue and clear like today. It might have been filled with dust, smoke, and strange gases. But why did life start on this empty Earth? How did the very first living thing appear when everything around it was not alive? Scientists want to find the answer. They look at old rocks, they study the ocean, and they use their best machines to look deep into space and deep inside the Earth. Every living thing that we see today needs a few special things. First, all life needs water. Water lets cells move and change. Water is soft and flows. It lets tiny parts join or break apart. Second, life needs some kinds of chemicals, such as carbon. Carbon is found in plants, animals, and even people. Third, life needs simple building blocks. These are called amino acids. When amino acids link together, they make proteins. Proteins help living things grow, break down food, repair parts, and do all the jobs needed for life. Where did the water and the right chemicals come from? Some people say the Earth made these things by itself. Maybe water appeared because the ground cooled and steam turned into drops and then into oceans and lakes. Maybe the building blocks formed when lightning hit the rocks and made them change. Some people, though, think that the answer is not just on our planet. They look up to the stars and wonder about space. Maybe, they say, some important things needed for life fell from the sky. This idea is exciting to many scientists. It means that the first seeds of life may have arrived here carried from far away in space. Science has many ideas about how life began. Some people think the answer is simple and only about Earth. Some think it is bigger and includes all the space around us. Nobody knows for sure. Earth was not always the green and blue planet we see now. In the early days of Earth, there were no forests or rivers. There were very few calm places. It was mostly hard rocks, open craters, and volcanoes. The land was dry, and the air around our planet was not safe to breathe. It had too much gas like carbon dioxide and hardly any oxygen. It is hard to imagine how even a very small cell could live in these places. The sun was hot, but sometimes clouds of dust covered the sky. There were big storms and the ground shook often. For many millions of years, our Earth stayed like this, empty and quiet. So, the question remains, how did life start here? Did it just appear one day from the rocks and water, if there was any water? Or did it need help from somewhere else? To find the answer, scientists look for clues. These are small facts that can help us build the story. Rocks hold some answers. The oldest rocks are like a diary left by the Earth. Inside them, pieces of chemicals are trapped. Sometimes, deep inside these rocks, we can find things that do not belong to the Earth. They may have come from far away, mixed into the ground long ago. When they study these bits under special microscopes or with strong tests, they find the signs of life's building blocks. They see patterns of molecules such as amino acids and sugars. Sugars give energy and take messages from one part of a cell to another. Amino acids join together to build proteins. But how did these important building blocks get to the early Earth, where there was almost nothing? This is the big puzzle. One idea suggests that our planet did not make all these things by itself. Instead, Earth got some of these materials from space. Very old stories from scientists say that long ago, big rocks and icy balls moved around the sun. These objects are called comets and asteroids. Asteroids are rocks, but comets are mixtures of ice, dust, and simple chemicals. When a comet travels close to the sun, its ice turns to gas and makes a bright tail. People have seen comets in the sky for many years. They are not part of any planet. They float and streak across space, sometimes getting closer to planets like Earth. Scientists wonder, what happens if a comet crashes into a planet? If a comet is made from warm water ice, dust, and important molecules, and it hits a dry, empty planet, could that help make life begin? The early Earth may have gotten many comet visits. The young planet's air was thick and dusty. There was not much water at first, no wide oceans and no lakes. Each time a comet crashed into the ground, it brought its own ice. The crash was hard and hot, but soon the ice would melt and form water. This water could collect in craters, making small ponds. Along with the water, the comet also delivered special chemicals and tiny building blocks. Over time, more comets hit the Earth. Sometimes the melting and mixing happened deep inside the planet. Sometimes it happened right at the surface, in a small pond made by a crater. The chemicals from the comets mixed with what was already on Earth. The air slowly changed. Some places had more water. The surface cooled down. More and more, the planet turned from dry and empty to a place that could maybe hold life. But how do we know comets carry the right things for life? Scientists try to answer this by looking at two things. First, they study pieces of rocks and ice that have fallen from space. Sometimes, in places like Antarctica, pieces of comets have landed and been buried in ice for a very long time. When these pieces are found and opened, they often hold amino acids, sugars, and other carbon chemicals. Second, scientists use robots and spacecraft to follow comets as they move through space. Robots can even collect dust from a comet's tail or surface. These bits are brought back to Earth and opened up in labs. When scientists look inside, they usually find what they hope for: amino acids, sugars, and other simple molecules needed for life. Every new clue makes the idea stronger that maybe life's building blocks did not all come from Earth. Maybe these important parts traveled across space, riding on comets, and fell here a long time ago. This would mean that space and our planet are closely linked. Life is not made only from things found on Earth, but from a mix of the two. The more clues we find in old rocks, the closer we get to answering the mystery, and the biggest question of all remains simple. Where did the first living thing come from? Some say Earth did it alone. Some say space helped. The answer might be a little bit of both. Science does not end with guessing. Scientists test their ideas. They make models of early Earth. They mix water, simple chemicals, and crush ice in a lab, trying to create the first tiny pieces of life. Sometimes these experiments make amino acids and sugars. Sometimes they show how easy it might be for life's building blocks to form. Sometimes the mix does not work and nothing new appears. Every experiment helps add a piece to the puzzle. All over the world, people look at stars, planets, and comets. We want to know, could life also begin somewhere else, far away? If comets can carry these important molecules from one planet to another, it is possible. Every comet that moves across the sky could bring these building blocks anywhere, anytime a young planet is ready for them. People have always wanted to know where we come from and how we began. Maybe the answer is right here, under our feet, and also far above us, shining in the night sky. The search for the first living thing is not finished. We are still trying to put together all the clues, one by one, to finish the story of how life began. To understand where the first building blocks of life may have come from, it is important to learn about comets. These mysterious travelers from space are not like the planets or the stars. They are smaller and do not stay in one place. Comets move through the sky, sometimes disappearing for a long time before coming close to the sun again. Even though comets are not very big, they have caught the attention of many people for thousands of years. When a comet comes close to Earth, it can shine brightly in the night sky and even have a long tail. Comets are very different from anything found on Earth. They are made from a simple mixture of ice, dust, and different types of chemicals. The ice that makes up most of a comet is frozen water, but sometimes it is also made up of other things, like frozen gases. Mixed inside the ice are tiny pieces of dust and rock. In the dust and ice, there are also simple kinds of molecules. These molecules are very important for the beginning of life. Many scientists explain comets as dirty snowballs because they are cold and have both ice and dirt. But this dirt is not just regular Earth. It is made with special tiny particles from space. Some of them formed before our planet ever existed. Scientists believe comets have been traveling around the sun for billions of years. They may be as old as the solar system itself. Comets come from two main places in space. One area is very far away and shaped like a large shell around all the planets. This is called the Oort cloud. Comets living there move very slowly and can stay in the cold for a very long time. They almost never come near the sun. The other area where comets are found is called the Kuiper belt. This region is beyond the last big planet in our solar system, past Neptune. The Kuiper belt has many icy bodies and leftovers from when the solar system began. Sometimes a comet from these areas gets pushed or pulled by the gravity of a planet and starts a long trip toward the sun. When a comet makes its long journey and gets closer to the sun, something special happens. The ice on the comet begins to warm up. Sunlight makes the frozen water and other gases turn into vapor. This vapor comes out of the comet and forms a glowing cloud around it and a long, shining tail that stretches behind the comet as it moves. This is why comets look so beautiful and bright when viewed in the sky. Not many people get a close look at comets, but scientists use large telescopes and spacecraft to see what they are made of. They use special machines to measure the light from a comet. From this, they can discover what types of chemicals are in the ice, dust, and gas. One reason comets are so interesting is because of the things they carry. The ice is important, but the chemicals inside are what matter most for understanding the start of life. Many tests have shown that comets hold molecules called amino acids. Amino acids join together to make proteins which are needed for all living things. Comets also often have other simple molecules such as sugars, which give energy in living bodies. Some of these chemicals might be older than the Earth itself. The path a comet travels can last hundreds, thousands, or even millions of years. Some comets move around the sun in short periods, such as every 75 years. Some take much longer and only come near the sun once in tens of thousands or even millions of years. During much of their journey, comets stay frozen, keeping their water, gases, and tiny molecules safe inside. Scientists find it exciting that comets are not picky about where they go. They can travel close to the sun, far into space, or near planets like Earth. If a comet gets close enough to a planet, it can sometimes crash into it. This crash is powerful and can release all the water, dust, and chemicals from inside the comet, letting them mix with the planet's own materials. Long ago in Earth's past, many more comets entered the inner solar system. Some of these crashed into the young Earth. Every time this happened, fresh water from the comet's ice melted. The chemicals buried in the comet were released and could join with things already on the surface of our planet. The crashes could have created small ponds and wet areas, places perfect for chemicals to mix and form something new. It is possible that after many crashes, the materials in comets mixed with those on Earth to give the very first building blocks for life. Besides amino acids and sugars, comets carry other important chemicals. Some are called nitriles, which are needed to build tiny parts of DNA, the molecule that stores information in every living thing. Others are simple carbon compounds. Carbon is a part of all living cells. The special thing about carbon is that it can join with many other atoms, helping to make big, complicated molecules like those found in living things. Because comets have all these important chemicals, scientists believe comets are a good match for the job of delivering life's building blocks. This makes comets different from asteroids, which are mostly hard rock and metal and might not carry as many interesting molecules for life. Astronomers have studied comets for hundreds of years, but only recently have people been able to visit them directly. Some spacecraft have flown close to comets and taken pictures. Others have tried to collect tiny amounts of dust or ice, bringing them back to Earth for careful study. Each new mission provides more evidence that comets are full of useful molecules for life. A few spacecraft have even landed on comets. One famous mission was sent by the European Space Agency. It was called Rosetta. Rosetta sent a small robot to touch down on a comet and look closely at what it was made of. The robot found that the comet had ice, dust, and several important organic chemicals, including amino acids and carbon-rich molecules. In another mission, a spacecraft called Stardust flew through the tail of a comet. It collected tiny particles from the comet's dust, trapped them, and later brought them back to Earth. When scientists looked inside these particles, they found amino acids and material similar to those found in the oldest meteorites. All this evidence helps build the story that comets carry the important parts needed for life. When scientists review what has been found inside these icy travelers, they notice a pattern. No matter if the comet comes from the Oort cloud or the Kuiper belt, many of them are filled with complex organic molecules. Sometimes the very same molecules that can be found in the cells of living things are present in comet ice and dust. Another reason comets matter is because they travel all over the solar system and even reach other solar systems. Some comets can leave the area near the Sun and travel into deep space. New comets arrive from the far edges on long orbits. This means that the building blocks for life are not only found on Earth, but in many places in the universe. Since comets can carry water and organic molecules to any place they land, if a young planet is forming somewhere and begins to get hit by comets, that planet may also receive these materials. If the conditions are right, maybe life could start somewhere else using the same process. Scientists have also seen young stars with disks of gas, ice, and dust around them. In these disks, comets and other icy bodies form. Sometimes big comets crash into the planets forming around the young star. This seems to happen often in the early life of a planetary system, just as it did with our Earth. Astronomers look for signs of comets around distant stars with special telescopes. They have already found evidence that comets are common everywhere we look. Some bright flashes of light or clouds of gas seen around distant stars are probably made by comets melting as they come near their new suns. Because comets are made of similar materials, no matter where they are found, it shows that the building blocks for life are spread widely through the universe. This makes scientists believe that the process which helped start life on Earth may be happening somewhere else too. If comets can deliver water, amino acids, and other organic molecules to many planets, it means the beginning of life may not be something special to just Earth. It is no longer just an idea from stories or dreams. Every experiment and each trip by a space robot gives new proof that comets play an important part. When we look at the evidence, we see how comets may have brought water and life's molecules many times, not just to Earth, but to other worlds as well. Because comets take so long to move around the sun, and because there are so many of them, these visitors can keep adding new materials to a planet for millions or billions of years. Each time a comet crashes, it brings a fresh batch of water and chemicals. The role of comets goes even deeper. When water from melted comet ice collects in a place on Earth, it does not just sit there. The water can mix with other chemicals that were already on the planet. Under the right temperatures and over a long time, these mixtures can create new and more complicated molecules. With every new crash, the mix becomes richer and more ready for something to happen, maybe even the first spark of life. Through careful study, scientists have found that some places on Earth, like the bottom of old craters or on the cold ground in Antarctica, have pieces of comets that fell long ago. These pieces are like small time capsules holding molecules and tiny parts that are billions of years old. When studied in a lab, these ancient comet pieces often show the signs of water, amino acids, and other life-related material. Every new discovery makes the connection between comets and life stronger. It teaches people that life is more than just what grows on the land and swims in the sea. Life's beginning is tied to the journey of icy rocks and dust through space. It is shaped by the paths of comets traveling far and wide, carrying the ingredients for life everywhere they go. As people learn more, the importance of comets only grows. They are not just interesting dots in the sky. Their tails are not just beautiful shapes. Inside each comet is a story of space, water, and organic chemistry. Each comet that rushes near the sun or travels across the night sky carries with it a hidden message, a sign that life's building blocks can travel from star to star, from planet to planet. The search for where life began does not stop. The more scientists discover about comets, the more questions appear. How many comets hit the early Earth? Did Earth's water mostly come from comets, or did it form in another way too? Why do so many comets have the very same molecules we need for life? Are comets bringing these things to other planets right now, helping to start new kinds of life far away? Many teams of scientists are working to answer all these questions. They use telescopes that can see far into space, searching for new comets. Others build spacecraft to visit comets or collect samples. Still more work in laboratories, mixing water, dust, and organic molecules in ways that copy what happens when a comet hits a planet. Through it all, the story becomes more clear. Comets are much more than icy bodies moving through the dark. They may be one of the reasons that water is found on our world. They may have brought the very first amino acids and other simple, living molecules to the empty, young Earth. Now, as scientists continue to dig deep into old rocks and study pieces of comets, they have found many signs pointing to a time long ago when these cosmic travelers had a huge effect on our planet. All of these discoveries remind us that the history of life is very old and goes far beyond what we can see today. Looking at comets is a way for us to look far back in time, to see not only what they hold, but also what they have given to worlds like ours. After learning how comets travel through space and can bring water and important chemicals to our planet, it is time to look at what the young Earth was really like. Earth has not always had blue oceans, soft soil, or green plants. The early Earth was a world that seemed very strange and even dangerous for anything trying to live. When the planet first formed, which happened more than 4 billion years ago, it was very hot. Most of the surface was covered in rock that was partly melted. There were volcanoes all over the planet, and they erupted often, sending lava and thick clouds of ash into the air. The ground shook because the inside of the planet was still moving and changing. These changes would happen for millions of years. The air was not like the air we breathe. It was filled with gases such as carbon dioxide, nitrogen, and a little water vapor. There was almost no oxygen. This means that no animals or people could breathe the air if they had lived then. The sky might look yellow or orange because of all the gas and dust. The sun would look different from how we see it now. Water on early Earth was very hard to find. There were no large oceans. If there was water at all, it would only be in small pools or lakes that came and went as the ground changed. Sometimes, tiny drops of water formed when vapor cooled after volcanoes released it, or when the surface of the Earth got a little colder, but there was not enough water for life to begin or grow. Everywhere, the ground was rocky or covered in new lava from volcanoes. Craters made by big impacts from space were seen all across the surface. These craters showed that objects from space, like asteroids and comets, were hitting the Earth very often, especially during the first few 100 million years. Each time a big rock or an icy comet collided with Earth, it made a huge explosion. The air became even dustier and hotter after these crashes. This kind of world was not a friendly place for life to start. Living things need water, shelter, and steady conditions. Early Earth changed all the time. One day a place could be cool and wet, and the next day it could be full of fresh lava and burning gases. Every part of the planet was new and always moving. Even with all these hard conditions, something special was happening. Every time a comet crashed on Earth, it carried water and chemicals that are useful for life. Some comets melted the minute they hit the ground, making puddles and tiny ponds in the craters. These small new bodies of water might last only a little while, but during that time, the materials from the comet mixed with the rocks, dust, and gases on Earth. Besides water, these comet impacts delivered amino acids and other simple molecules. As more comets arrived and spilled out their insides, the collection of useful chemicals on the surface of Earth grew bigger and bigger. Each impact was another chance for life's building blocks to mix together. Even with all this mixing and water arriving, life still had big problems. The temperatures on early Earth were almost always too high or too low. Sometimes the surface cooled for a short time, and small puddles of water could stay for days or even weeks. Other times the heat would return and dry everything up. The Earth slowly began to cool. As the surface cooled, more of the water from comets and volcanoes turned into liquid. Over millions of years, tiny lakes and small seas began to form. These were not as big as today's oceans, but they were the first safe places where life could try to start. Scientists know about these early conditions from studying old rocks. Some of the oldest rocks on Earth, which are more than 3 billion years old, tell the story of wild volcanoes, hot lava, and lands that never stayed the same for long. Some rocks hold signs that water flowed through them once, even if it was only for a short time long ago. Other rocks show signs that things from space mixed with Earth's materials. In some places, scientists have found small pieces of comets or meteorites trapped inside ancient stones. These space pieces often hold the same kind of molecules that help life to start. There are amino acids, simple sugars, and other carbon-based chemicals. The air on early Earth made it even more difficult for life. There was no ozone around the planet to help block the harmful rays from the sun. These rays could break down important chemicals, making it hard for the first living things to survive. The land was also covered with lots of rocks and not much protection from heat, cold, storms, or space impacts. Scientists have tried to copy the air of early Earth in their labs. When they mix the same gases, carbon dioxide, water vapor, nitrogen, and add sparks to copy lightning, they sometimes make amino acids and other small molecules. These experiments are exciting because they show that nature finds a way to put together simple pieces even in tough conditions. Still, for life to have a chance, all the right parts needed to come together in places that were safe, even just for a short time. This is why the idea of small ponds or craters filled by comet water is important. These places may have protected some chemicals and allowed them to connect together. When conditions changed, they could try again in a different place or at a different time. Another problem was the lack of oxygen. Today, all animals and people need oxygen to breathe. But the earliest forms of life did not use oxygen. If life did start in small ponds or lakes, it had to be able to grow without using oxygen. Scientists think the first living things used other types of energy that did not need oxygen, like chemicals from rocks and water. The story of early Earth teaches us that life needs more than just one thing. It must have water, the right chemicals, and also a safe place to let those chemicals come together. The young Earth did not have many safe places, but comets helped by bringing more water and special chemicals over millions of years. While the surface of Earth was changing, deep below, the planet's inside was also still hot and moving. Sometimes, water from comet impacts would go underground, getting trapped in rocks or mixing with hot gases. This made changes to the minerals and could create new kinds of materials. Some scientists think that these deep places in the rocks, where water and chemicals mix, could also have been a place for life to start. In some ways, the early days of Earth can still be seen in a few places today. Places like volcanic islands, hot springs, or deep ocean vents show us what the young planet might have looked like. In these places, water is hot and full of minerals. Even now, simple forms of life can live there without oxygen or sunlight, using only simple chemicals for energy. When scientists look for signs of the first life, they search in old rocks for patterns made by tiny cells or for chemicals that only life can make. Some rocks from Western Australia and Greenland are older than 3 billion years. Inside them, there are special layers that may have been formed by very simple living things, probably tiny cells that lived without much oxygen, using the chemicals brought by comets and volcanoes. The cooling of the planet slowly allowed more water to stay on the surface. Pools and ponds began to join together to make small lakes and seas. Over millions and millions of years, these small seas grew larger and larger until the first oceans started to cover the planet. These new bodies of water gave more places for chemicals to mix and start new reactions. These new and bigger areas of water helped keep temperatures from changing too quickly. This helped protect any forming life from heat and cold. Still, volcanoes and asteroid impacts could bring sudden changes. Even so, the steady growth of water on the planet made it possible for life's building blocks to gather in larger places, which helped more complex molecules form over time. Earth was also still being hit by comets and asteroids, and each new crash could bring more water and different types of simple chemicals. The more water and chemicals that built up on Earth, the better the chances for life to start somewhere, in some small corner where all the right conditions came together. When looking at other planets and moons in our solar system, scientists see places that might look like early Earth. For example, Mars and some moons of Jupiter and Saturn show signs of old volcanoes, rocks, ice, or even old water. These places probably had their own history of impacts from comets or asteroids too. Scientists believe that if life could start on a difficult world like the early Earth, maybe it could also start on other planets with similar stories. The idea that comets can deliver water and chemicals is very important for other worlds, not just for Earth. In the oldest times, Earth had no layers of rich soil to hold plants, no trees for shade, no animals to eat plants, and no people to walk and think. Instead, everything was rough and new. The only things growing or changing were the land and air itself. Yet, something amazing was beginning. Step by step, with every new comet, with every bit of new water, the ingredients for life became a little more common and mixed on Earth. The chemistry that started in those small ponds, lakes, or even underground might have been simple at first. But as time went on, simple molecules joined together and got more complex. With every new cycle of wet and dry, hot and cold, the basic pieces of life had more chances to link up and try new shapes. Every scientist who studies this time knows that early Earth gave life a hard test. There was not much water at first, but arriving comets helped to change that. There were not many safe places, but small ponds from impacts gave special short chances. The planet's air did not have what we breathe today, but early life grew anyway, using other ways to get energy. Any life that started during those first hundreds of millions of years had to survive harsh changes. Even when life began, it was likely very simple, just small, tough cells that could live in water without much oxygen or light. These small cells did not move or grow fast. They did not have eyes or mouths, but they started the long story of life that would someday lead to plants, animals, and people. The importance of the young Earth is in how it set the stage for life. Without those first pools and lakes filled with water from comets and chemicals from space, there would be no way for the building blocks of life to join. Each crater made by an impact was not just a hole, but a chance for new things to happen. As the planet cooled and the water on Earth grew, the number of places where these building blocks could mix became greater and greater. Each new pond, lake, or sea was another chance for life's ingredients to get together, make bigger molecules, or even copy themselves for the first time. Today, the story of the early Earth reminds us that life needs more than one thing. It cannot begin unless there is water, the right chemicals, and a safe place for these things to mix. What comets brought to Earth may have made all the difference, turning a dry and dangerous world into a place ready for life's first steps. No matter how hard early Earth seemed, the journey of comets, bringing water and useful molecules over millions of years, helped turn it into a home where living things could finally begin. These small steps, taken by nature with every new impact, made it possible for Earth to move from a place of just rocks and lava to a living world full of oceans, clouds, and later, all kinds of life. The story did not stop there. As soon as there were enough ingredients and safe places, something new and special started to happen in the waters and rocks of that early world. As Earth became cooler and water started to stay on its surface, the planet slowly filled with more ponds, lakes, and even the first small oceans. Many of these were made or shaped by impacts from comets and asteroids. Each time a comet crashed into Earth, something important happened. The comet carried ice, dust, and simple chemicals inside it. When the comet hit the ground, the crash was very powerful and created a deep hole called a crater. The heat from the crash melted the ice inside the comet. This new water ran into the hole and made a small pond or lake. These new pools did not just have water. They also contained the special chemicals and molecules that came with the comet. The ground around the pond held the dust and rocks from the impact, and now everything began to mix. With every comet impact, more water and new molecules were added to Earth. Some of these molecules were very simple, but others were already starting to form more interesting groups, like amino acids. These are the basic building blocks needed to make proteins. Proteins are very important for living things, and without them, life cannot grow or work. The arrival of comets did not happen just once. Over millions of years, thousands of comets crashed into Earth. With each crash, more water and more chemicals were added. Some impacts were small, while others were so big that they changed large areas of the planet. The most important thing was that every impact gave Earth new chances for life's building blocks to combine in different ways. Inside the small ponds and craters left behind by these impacts, the water stayed for days, weeks, or maybe even longer. During this time, the chemicals could move around, join together, and form new shapes or groups. Sunlight shined on these ponds, and the changes from day to night made the water heat up and cool down. This helped the molecules in the water to try new connections. Some of them could stick together, while others could break apart and start again. The chemicals from comets did not only land in water. Some of them mixed with dust and rocks on the ground. Sometimes, rain or waves would wash them into lakes and rivers. As more and more water arrived from comets and volcanoes over millions of years, the Earth's surface gave more places for these important molecules to move and mix. Some scientists think that the most important changes happened in these small ponds after a comet impact. When a crater filled with water and chemicals, the conditions inside could be just right for new molecules to form. If the water dried up a little, the molecules would come together more closely. When it rained or more water was added, they could start moving and joining up in new ways. These ups and downs in water level helped to make more complex groups of molecules over time. Amino acids, sugars, and other carbon-based molecules needed the right mix of water, heat, and time to form bigger and more important molecules for life to begin. As more comets continued to crash, the amount of these special ingredients grew on Earth. The planet slowly changed from a dry and empty place to one with many wet spots, all filled with useful building blocks. Scientists have tried to understand just how much water came from comets. When they look at the water in Earth's oceans, they compare it to the water in comets. Some of the tiny parts inside water, called isotopes, are special and rare. By measuring these tiny differences, they find that much of Earth's water probably did come from comets over a very long time. Each comet brought its own type of water, and over millions of years, all of these mixed together to make the oceans we see today. The process of comet impacts was not always gentle. The crashes were violent and brought heat, light, and shock to the planet. In some cases, the heat would break apart molecules that were already formed, but soon after, as things cooled, the water would let new molecules form again. Even though the impacts were rough, they made sure that Earth got a steady supply of water and molecules for a long time. Water and chemicals from comets also helped to make the first atmosphere on Earth thicker and more useful for life. Each crash made new gases rise into the air, including water vapor and carbon-based molecules. Over time, this changed the kind of air above the Earth and helped to protect the surface from the sun's harmful rays. While the early oceans were still small, each new comet impact brought more water. Some impacts were big enough to change whole regions of the planet. Others were smaller, just adding a little water and chemicals to one spot at a time. As this went on, the total amount of water on Earth kept growing. New lakes, ponds, and streams appeared everywhere that the ground could hold them. The same process was happening on other young planets and moons. Sometimes, a comet would miss Earth and hit the Moon, Mars, or other bodies in space. These impacts made craters on each of those planets and sometimes left behind water and chemicals too. It is possible that, in the past, Mars got some of its water in the same way as Earth, by being hit by comets. The water from comets did not always stay at the surface. Sometimes it seeped into cracks in the rocks or went underground. In some places, the heat from the inside of the Earth would make this water rise back up in hot springs. These underground lakes and hot spots could protect some chemicals and let them change slowly, safe from the storms and impacts above. The combination of water, heat, and chemicals in small, protected places gave life's building blocks many chances to join together. In some ponds, pools of water dried up during the day and then filled again when it rained. When water disappeared, molecules were pushed close together and could link up in new ways. When it rained, they could spread out and move again. Over many years, this back-and-forth action helped simple molecules join into longer chains and more complicated shapes. Scientists today do experiments to see what happens when they copy these old conditions. They mix water, dust, and chemicals like those found in comets. They heat and cool the mixtures, let them dry, then add water again. Many times, new and interesting molecules form in the lab, molecules that are needed for cells and living things to exist. The chemicals from comets mixed with water and carbon chemicals from volcanoes and the planet's surface. Sometimes lightning storms would strike the ponds, adding energy to the water and helping reactions to happen. Sunlight during the day gave more energy. All of these things together made the perfect setting for tiny building blocks to slowly join into more complex forms. Over time, as more water collected and more chemicals mixed, small pools began to join together into larger lakes and shallow seas. The bigger the pond or lake, the more chances there were for these building blocks to meet and connect. The shallow edges of ponds, where water would dry and then fill again, were special places. Here, new molecules would form and sometimes stick together, making even larger and more important pieces needed for life. The process of comet impacts lasted not just for a few years, but for hundreds of millions of years. The steady rain of comets into Earth's atmosphere was like nature's way of delivering all the water and important molecules in many small steps. Because there were so many comet crashes, life's building blocks could be spread all over the Earth in every continent and ocean basin from its earliest days. When the building blocks collected in large enough numbers, something new started to happen. Molecules linked up into chains, circles, and layers. Some became so complex they could store information or copy themselves. These are big steps on the road from non-living things to living things, and all this could have started in the simple ponds and craters left by comets. The water from comets also made new kinds of rocks and minerals form on the surface of the Earth. When hot lava met cold water, strange kinds of glass and stone were made. Some of these rocks trapped molecules inside them, protecting them from heat and pressure. When these rocks later broke open, the molecules inside could be released into new ponds and lakes. As Earth cooled more, the first small seas joined together. Now, waves carried molecules, water, and fine dirt across bigger areas. This movement helped mix everything even better, giving the chemicals new places to meet and react. Over millions of years, the first big oceans began to form, and all the water from countless comet impacts became part of the oceans we know now. This mixing did not just help form water and chemicals. As more water gathered, Earth got a more stable temperature. The oceans kept the planet from becoming too hot in the day or too cold at night. This made it easier for the first forms of life to one day survive, even as the world changed. All around the planet, in every place that could hold water, there were now ponds, lakes, streams, and shallow seas filled with molecules from comets and the Earth itself. Each place was like a test area where new combinations of molecules could happen every day. Some combinations lasted, while others broke apart and were tried again. As the number of molecules and water grew, the air above the surface also changed. more water vapor, more carbon-based gases, and the chemicals from every impact helped make a thick blanket of air around the planet. Over time, this shield made it safer for water and useful molecules to stay at the surface, safe from the sun and safe from being lost to space. The story of how comets delivered water and chemicals is shown in the rocks and water on Earth even today. Scientists find tiny bits of material in the oldest rocks that match the chemicals found in comets. Sometimes, in the oldest ice in Antarctica or in old pieces of rock from the ocean floor, they discover pieces of comets trapped for billions of years. Each discovery adds more proof that comets helped make Earth into a place where life could begin. Scientists are still learning and doing more experiments. Sometimes they find old craters with signs that water once filled them, even though they are now dry. These old craters are clues that comet impacts brought not just water but also the important molecules needed for life. Even now, comets still pass near the Earth. Sometimes a tiny piece breaks off as a meteor. When these small shooting stars make it to the ground, they often hold the same chemicals as the big comets from billions of years ago. What fell long ago still falls today, reminding us of how much comets have helped shape our planet. The journey of water and chemicals from comets did not stop when the first oceans formed. For millions and millions of years, new comets brought more of the building blocks. These kept mixing with what was already on Earth, making bigger and more complicated molecules. The pools and lakes formed by impacts slowly changed into deeper and saltier seas. These new seas offered different conditions for chemicals to join together. Layers of mud, sand, and rock at the bottom of the seas trapped more molecules and sometimes protected the most important ones from heat or storms. As the supply of water from comets slowed down, Earth now had enough water to keep oceans, rivers, lakes, and even underground streams filled. This stable supply of water helped set the conditions for new steps to happen. With more water, bigger molecules could try new forms, and the first simple collections of life's building blocks were ready to make another change. The long story of comets bringing water and important chemicals to Earth is a story that helped turn a dry, hot planet into a place where life could really begin. Today, the water in every lake and ocean can be traced back to these ancient impacts. Every drop carries a history of space, time, and millions of small steps taken by comets crashing to the Earth. This journey of delivery and mixing is not just about water or single molecules. It also made possible the new forms and bigger structures that life needs. When the right mixture of molecules, water, heat, and time was found in the ponds, lakes, and seas left by comets, the most basic forms of life's ingredients started to change again, this time into something even more rare and special on our planet. As the water and chemicals gathered in the ponds, lakes, and early oceans, the next important step was the appearance of larger and more special molecules. Among all the chemicals that arrived from comets, a group called amino acids turned out to be very important. These tiny pieces are needed by every living thing on Earth. With water all around, places full of amino acids, sugars, and other carbon molecules soon became more common. All these small building blocks mixed together in many different ways, helped by the warmth of the sun and the changing conditions on early Earth. Amino acids are not hard to understand. Each amino acid is a simple chemical made from atoms of carbon, hydrogen, oxygen, and nitrogen. There are many kinds of amino acids, but only a small number are needed to make the proteins that help living things grow and survive. Comets brought these amino acids to Earth, each impact adding more to the ground, ponds, and seas. At first, amino acids floated freely in the water, mixing with other simple chemicals like sugars and small pieces of carbon. Proteins are made up of long chains of amino acids joined together. When proteins are built, they can do many jobs inside a living thing. Some proteins help move chemicals, others help store energy, and many are needed for building the parts of a cell. Without proteins, life cannot exist. That is why the discovery of amino acids in comets is so important for the story of how life began. Scientists study the oldest rocks and meteorites to learn what kinds of amino acids and other simple molecules were here before life started. They find that, even billions of years ago, amino acids were already present. When these are compared to the amino acids in comets and meteorites, they look very much the same. This shows that comets did not just bring water to early Earth, but also the important building blocks that are the very start of life. When amino acids gather in water, they can sometimes connect together to form longer chains. Heat, sunlight, the drying and wetting of the pond, or even special kinds of rocks can all help to join these amino acids and make proteins. These proteins may have started as tiny strings, but over time, more complex and useful shapes appeared. In many laboratory experiments, scientists have seen amino acids joined together to make simple proteins if the right mix of water and heat happens. Along with amino acids, comets brought other small, helpful molecules. Some of these are sugars, which can give energy to cells. Others are simple carbon compounds that can be used to build bigger and more complex molecules. All living things are made mostly from carbon. This is why finding carbon compounds in comets is so important for understanding the history of life on Earth. Each new group of amino acids, sugars, and carbon compounds could make the water richer. The more building blocks there were, the more chances there were for new combinations. Some mixtures broke apart quickly, but others stuck together for longer. With each day and night, with every wet and dry cycle, the most successful combinations lasted and changed more. Proteins are not the only thing needed for life. There are other special molecules too. Nucleic acids, which can carry information, need the right pieces to form. Some of these pieces were made by mixing chemicals from comets, the land, and the early ocean. There are also lipids, which are molecules that help form the walls of cells. Fatty acids, one kind of lipid, have been found in meteorites and comets as well. The early seas and ponds became a place where thousands of chemical reactions could happen every hour. Water gave the molecules a place to move and meet. Heat from the sun or the inside of the earth gave them energy. Sometimes lightning, called electric sparks, would hit the ponds and help even more reactions happen. Over many years, the ponds and seas became full of chains of amino acids, sugars, and many other simple molecules. This mix of chemicals was always changing as new water and fresh material arrived from space and from the land. When scientists look at these ideas in their laboratories, they try to mix water, amino acids, sugars, and carbon molecules in ways that copy the early Earth. In some experiments, after a few weeks or months, long chains of amino acids form by themselves, and sometimes small groups of molecules join into little bubbles. These bubbles can trap water and other necessary parts inside, just like a very simple cell would do later in the history of life. Some of the most interesting discoveries come from old ice and rocks found in Antarctica or the bottom of the sea. Inside these, scientists find the same kinds of amino acids and sugars that are needed for life to build itself. In some of the oldest rocks, there are patterns made by layers of chemicals, and sometimes tiny bubbles are found, frozen in time with the chemicals that once moved in the ancient water. These building blocks of life brought by comets and made on Earth are not alive by themselves. They do not move, grow, or copy in the way living things do. But when they join together in certain ways, they could begin to do special jobs, like some of the tasks proteins do today. If the right mixture of building blocks came together, a new step could happen. These groups could start copying themselves, which is needed for true life to grow and multiply. Amino acids, sugars, and carbon molecules are found across the universe. Scientists who study comets and meteorites from faraway places often find these same molecules. This means that the building blocks of life can be made in space and can move from place to place, riding inside comets as they travel to different planets. This discovery is important because it suggests that life's basic parts may not be rare or special to Earth alone. If comets can bring the same amino acids, sugars, and carbon compounds to other planets, the first steps toward life might also begin somewhere else if those places have water and the right conditions. Every living thing on Earth needs proteins. Plants use them to build their green leaves and roots. Animals use them for muscles, skin, and to carry signals. Little cells, as small as 1/1,000,000th of a meter, are filled with these proteins, working every moment to keep everything alive. The fact that these molecules came from comets long ago means that the history of life is shared with space. Every cell, plant, animal, and person is deeply connected to the story of comets carrying the first building blocks of life to Earth. Over many millions of years, as more comet impacts happened and more water and chemicals arrived, the chemical soup of the early ponds and seas kept changing. The most stable and useful amino acids and sugars stuck together, forming larger groups. The ones that could do special jobs, like holding on to energy or helping to make new molecules, were the ones that lasted the longest. Some of the first big changes happened when the right chains of amino acids formed. These chains could become proteins that helped speed up other chemical reactions. When a reaction happens faster, more new molecules can join together. In this way, the mix of chemicals became more rich and active with every new day and night. Fatty acids, which may have also come from comets or formed on Earth, made another big change possible. These molecules could join and make little bubbles in water. These bubbles created small, protected spaces where the other building blocks could gather together, safe from the outside. This step was important for the later rise of real living cells. The first simple forms of what would become life likely started as groups of molecules inside these bubbles. Some chains copied themselves and made more, while others helped reactions happen faster. Each small step made the bubbles more like cells, with parts that worked together better and better over many millions of years. Scientists today try to see each step, one by one, in their experiments. They mix water, add amino acids and other chemicals, and sometimes use heat or electricity to help reactions start. They watch how chains form, how bubbles appear, and how some groups of molecules last longer than others. Sometimes they see simple copying happen, a sign that they are getting close to the kind of chemistry that made the first living cells on Earth. All these experiments show that it is not too hard to make simple building blocks from the same materials found on early Earth and in comets. Time, water, and energy bring these blocks together in many ways until the best and most useful ones last. The variety of amino acids brought by comets helped make many kinds of proteins possible later in life's history. Because there were many different types of building blocks, early forms of life had more ways to react with energy, store it, and use it in new ways. This made it easier for life to get started and to change as the world itself changed. The same kinds of simple molecules found in comets have also been found on other planets and moons in the dust and air above them. This is more proof that the building blocks of life belong not just to Earth but to the whole universe. When amino acids joined into longer chains and formed proteins, when fatty acids joined into bubbles, and when sugars stored energy, the stage was set for one of the most important steps toward life. Some of these molecules learned to copy themselves. This was the first hint of something alive forming for the first time. The story of life starts with water and chemicals brought by comets. Every second that went by on early Earth, more tiny building blocks mixed and joined. Sometimes everything fell apart and started over, but over millions of years, more and more stable patterns appeared. When proteins began to make reactions faster, and when bubbles of fatty acids gave protected spaces, the earliest tiny systems could keep going and growing. Bit by bit, the world of chemistry grew into the world of life, all because comets brought the simple, important molecules to join with what Earth already had. This slow joining of building blocks led, step by step, to the first real life. Simple, but able to make copies and use energy. A new thing on Earth and maybe one day on other worlds. Even now, scientists work every day to learn more about the building blocks of life. They look for amino acids, proteins, sugars, and fatty acids in space, in rocks, and in their laboratories. Each new experiment and each new discovery helps us understand a little more about how our planet, with help from comets, went from a world of rocks and water to a world filled with all the living things we see today. This story continues at every level of life, from the smallest cell to the biggest plant or animal. It all starts with tiny building blocks brought together in water, joined with warmth and time, ready for the next change that would make life possible on this special planet. The search for answers about the first building blocks of life does not only happen in laboratories or through imagination. Scientists also look for real clues in nature. Clues that are hidden in the oldest rocks on Earth and in the new samples that come from space. These rocks and samples are like letters sent from the far past, helping to tell us what happened many billions of years ago when our world was very different. Some of the oldest rocks found on Earth come from places like Greenland, Western Australia, and Canada. These rocks have lived through almost the entire history of our planet. When scientists study them, they look for special marks and traces, small pieces inside the rocks that do not belong to the rock itself, but were brought here long ago. Some of these pieces are from comets or meteorites that crashed into Earth when the planet was still very young. Inside these ancient rocks, scientists sometimes find molecules that are very short and simple, like amino acids. Amino acids are important because they are needed to build proteins, which are part of all living things. Even more exciting, sometimes there are sugars or other tiny carbon-based molecules inside these rocks, many of the same ones that are carried by comets today. There are also marks made by changes in the rocks, showing that water once passed through them. This matches the idea that ponds or lakes were formed by comet impacts, and that water and molecules from comets mixed with the Earth's surface for a long time. Some rocks from Antarctica are even more special. Antarctica is very cold and covered with ice, which helps to protect things that fall from space. Over the years, pieces of comets and meteorites have landed there and stayed preserved in the ice. These are called meteorites, but scientists know that some of them started as comets. They look inside these meteorites for special molecules. Many times they find not just amino acids, but also fatty acids, sugars, and even very simple pieces of DNA and RNA. These are the special molecules that can store information in living things. These findings help show that the same molecules used to build life on Earth also traveled here from space. They are not made only by Earth. Instead, they can come from places deep in the solar system or even farther away. When these meteorites and comet pieces are found, they are carefully taken to special laboratories. There, scientists use strong microscopes and powerful tests to discover every molecule hiding inside. Sometimes the shapes or patterns inside old rocks show steps on the journey from non-living chemicals to living cells. For example, some rocks have thin layers, almost like sheets in a book. These layers are made of different chemicals that were left behind by water or by tiny cells if there were any at that time. Sometimes there are round marks called microfossils. These are much too small to see without a microscope, but they suggest that tiny living cells may have started to appear billions of years ago. Spacecraft have made it possible to test what comets are made of right now. In the last 50 years, scientists have sent rockets and robots to study comets up close. One famous spacecraft, made by the European Space Agency, was called Rosetta. Rosetta chased a comet for years. When it arrived, it dropped a small robot onto the icy surface. That robot was able to collect ice, dust, and gas, and it measured the kinds of molecules found there. The scientists were amazed to find that the comet was filled with amino acids, sugars, and simple pieces of carbon, the very same building blocks that are needed for life on Earth. Another spacecraft, made by the United States and called Stardust, flew through the tail of a comet. It collected dust and tiny bits of ice as it went. When this dust was brought back to Earth and studied in the laboratory, scientists found that the comet dust also contained organic molecules, amino acids, and other pieces just like those in the oldest Earth rocks. These discoveries from both ancient Earth rocks and new space samples tell the same story. The ingredients for life are everywhere. They are in old rocks, new comets, meteorites, and space dust. They have come to our planet many, many times, carried by comets that have crashed on the ground, melted into ponds, or fallen through the air as dust and small pieces. The careful work of studying these samples is done by many people in many countries. The process is slow and careful. When a new meteorite or comet piece is found, it must not be touched by human hands or regular air, so nothing from new living things gets inside. All testing is done using special suits, tools, and clean rooms. In these labs, scientists break open the rocks or ice and collect the gases, water, and molecules inside. The scientists then use machines to look at every part of the sample. They look for patterns made by chemical bonds. They try to tell if a molecule came from Earth, from a volcano, from an ocean, or from a comet far out in space. When the same kinds of amino acids and other simple molecules are found in both comets and old Earth rocks, it gives strong evidence that comets helped bring these things here. There are also other tests that scientists do. Sometimes they use tools to look for the age of the rocks and the age of the molecules inside them. This is done by measuring tiny changes in the atoms. If a molecule is very, very old, older than Earth's first living things, it may have come from a comet. These age tests match the story that life's building blocks have come from many places over billions of years. Scientists also use another kind of study called isotope tests. Isotopes are slight differences in the same kind of atom, like a tiny fingerprint. Water, for example, can have different kinds of hydrogen and oxygen atoms. By looking at the isotopes in Earth's oceans and in comet ice, scientists discovered that much of Earth's water matches the water found in comets. That means not only the molecules, but even the water in our seas may have first traveled here from far away in space. Special machines help scientists find the difference between molecules that formed on Earth and those that came from space. Sometimes this difference is shown by the shape of the molecule, the kind of atoms inside it, or the way it is stuck together. Over many years of work, scientists have found strong proof that at least some of the most important parts of life, like amino acids, are the same in space and on Earth. In some cases, rocks deep under the ocean have been found with layers of chemicals that match what scientists expect to see from comet impacts. These rocks can be billions of years old. They may have formed right after a comet impact, then been buried by mud and sand. Inside these layers, the same amino acids and simple sugars have been found. Every test, every discovery, and every new sample helps put more pieces into the story of how life started on Earth. A big part of this story is that Earth alone did not make everything needed for life. Space helped. Comets, meteors, and dust from the solar system helped deliver water, amino acids, sugars, carbon, and more. Some scientists use computer models to test how often comets and meteorites fell to Earth long ago. These models use information from rocks, the moon, and space samples. Most show that there were many thousands or even millions of impacts in the early time of the planet. With each impact, more water and chemicals came. There are still small impacts today. Even now, some dust and small pieces from space arrive on Earth every day, sometimes as shooting stars. Telescopes are also used to watch comets before they come near. By measuring the light from a comet's tail and head, scientists can tell what kind of molecules are inside. Many times, they have seen the same kinds of organic molecules that are found in life on Earth. One of the most exciting pieces of evidence came from the Stardust mission. When scientists looked at the samples Stardust brought back, they found a kind of simple amino acid called glycine. Glycine is one of the building blocks needed for proteins. The same kind of glycine is found in Earth rocks, comets, and living things. There are even special rocks found in the oceans and frozen land called carbonaceous chondrites. These are dark, heavy meteorites that are filled with water, organic molecules, and sometimes even little bubbles trapped inside. When scientists melt these meteorites and look at the gases and liquids inside, they find clear matches between comet materials and parts of living things. Even the oldest known rocks in Canada and Greenland sometimes have signs of molecules that look like what is found in comets. Sometimes these are just simple chains, but sometimes there are more complex shapes. Some scientists believe these chains are the beginning of the proteins and sugars needed for life. They are not alive, but they are one step away from joining together to form something new. The discovery of sugars in space was also a big moment. Sugars are simple molecules. They help store energy for living things and are needed for the bigger molecules that carry information in life. When sugars were first found in meteorites, it helped prove that space can create the same important molecules seen in all living plants and animals. When all this evidence is put together, the story is strong. All over the world, in rocks, lakes, ice, and from missions in space, scientists keep finding proof that the pieces for life's puzzle were made and moved around by comets, meteorites, and dust. Every test and every rock makes the story more clear. Some scientists also study the moon because it has old craters from impacts. Even though there is not much water there, they sometimes find small molecules brought by comets or meteors. Mars is another place where tests have shown some simple organic molecules, maybe from its own comets. With all of these signs, it is easier to understand how Earth's ancient ponds, seas, and lakes collected so many useful building blocks. Each comet and meteorite helped, sometimes bringing a big splash of new water, sometimes only dust or a group of sugars and amino acids. Over millions and billions of years, these gifts from space added up to make the early world full of the right kinds of chemistry for life. Not every impact from space helped. Some were too hot or too strong and broke apart important molecules. Others, though, delivered just what was needed for life to try something new. The combination of steady impacts, gentle ponds, and safe places on Earth allowed the most useful molecules to survive and join together. To study all this information, scientists also use experiments that look like real impacts. They crash pieces of rock and ice together at high speed using strong machines. Then they look inside the new rocks and water to see if amino acids or other special molecules are made. Sometimes these tests show that heat and pressure help build new molecules very much like those in living things. Looking at all these clues together, scientists see a world that was always changing in the early days. It was a place where Earth's own chemistry met the gifts brought by comets. Each new discovery, whether it is a piece of ancient rock or dust from a passing comet, helps finish the story just a little more. The rocks, ice, and dust from space continue to arrive, even in our time. Every year, new meteorites are found in deserts, in Antarctica, and in other places. Some of these recent stones still have the building blocks needed for life. Studying them helps make sure the story is right. By collecting and studying all these clues, from the oldest rocks, the coldest ice, the deepest sea, and the farthest space, humans are learning step by step how life's important parts were first gathered to Earth. Each clue is a piece in the puzzle of how the first living things may have started to appear and how the journey from simple molecules to life began. These discoveries are not just about looking back. They are about understanding how everything alive today is connected to the history of our planet and to the rest of the universe. After finding so many clues in rocks, ice, and comet dust, the story of how life got started on Earth becomes a story about growth, step by step, from the simplest chemicals to living things. It is not a short story, and it is not simple. It took millions and millions of years for the first forms of life to appear. The early planet was filled with water, amino acids from comets, sugars, small carbon pieces, and many other chemicals. But all these things were not alive yet. They were just tiny building blocks, still waiting for a big change. In places where water stayed for a long time, ponds, new lakes, and shallow seas, these small molecules moved around, mixed together, and sometimes joined to make something a little bigger. During the day, sunlight warmed the water and made some reactions happen faster. At night, the air got cooler, and sometimes water would dry up a little, making the molecules come close together. When it rained or more water arrived, things got to spread out again. Amino acids, the simple molecules brought by comets, could link up in the water. When they joined, they became chains called proteins. Proteins are very useful because they can help to do all sorts of small jobs that make life possible. There are many kinds of proteins, built from different amino acids, and each kind is useful for different things. Sugars, another gift from comets and from reactions on Earth, gave energy to the molecules in the water. Sugars can also help make bigger parts, like the backbone for more important molecules needed by living things. As time passed, more and more complex molecules began to appear in those warm, wet places. Some of these molecules joined to make bubbles. These bubbles were very small, much too small to see without a microscope. Still, these bubbles had a very important job. They helped to trap water and chemicals inside, making a space where reactions could happen safely and slowly. Inside these bubbles, proteins, sugars, and carbon molecules started to work together. Sometimes, a group of molecules inside a bubble would help to make new copies of themselves. None of these bubbles was alive yet, but they were closer to life than the single amino acids or sugars floating in the water. Scientists believe steps like this, the joining of chemicals into bubbles, were very important for the very first cells. One important thing for life is the ability to make copies of itself. Scientists use the word replicate for this. Molecules that can replicate or copy themselves have the first sign of something living. Over millions of years, by mixing, heating, cooling, and sometimes joining in bubbles, some special chains of molecules learned to copy themselves. As soon as this could happen, evolution started. This means small changes happened over time, and the ones who did the best job of copying themselves lasted longer or made more of themselves. The simplest forms of life were probably tiny, simple cells. They were much smaller than a grain of sand, so small that you need a microscope to see them. These early cells could take in water, grab small chemicals for food, and make new copies of themselves when the time was right. They did not have brains, eyes, or even a mouth. They were just tiny bubbles filled with important molecules from the ponds, lakes, and seas. Every part of these first cells was built from the molecules brought by comets and mixed in Earth's water. The proteins let the cell do small jobs, like breaking down food or helping other chemicals get into or out of the cell. Sugars gave quick bursts of energy. Other important molecules could hold on to information about how to build a new cell. The best mixtures worked better, so the cells that had the right mix could last longer and copy themselves more. As the first cells learned to survive in Earth's early oceans and ponds, they started to change the world just a little. They used up the chemicals around them and made new ones as waste. Sometimes waste became important to other cells, who could use it in different ways. Over millions of years, the small, simple chemistry of the early planet became busier and more complicated, all because these first cells could copy and change. There were many challenges for these simple cells. The world was still sometimes very hot or cold. The sun's light could be too strong, and volcanoes or impacts from space still happened from time to time. Life would sometimes start to grow and then be pushed back by a big change, like a dry spell or a hot rock flow. But the process did not stop. Safe places could be found, and life tried again and again. Scientists are able to see some of these changes even now. In the oldest rocks, small patterns or thin layers can show where the first groups of cells lived. These layers are sometimes made by lots of cells living close together over time, leaving a record in the mud or sand that later turned to rock. These ancient rocks are found in Western Australia, Greenland, and a few other places. They are more than 3 billion years old. Inside them, only the very smallest fragments of life can be seen, but these are the first traces of life on Earth. Little by little, as cells learned new ways to survive, some joined together into bigger groups. Instead of living all by themselves, they formed colonies. This did not happen right away. For billions of years, most life stayed very simple, just small single cells. But sometimes, in some places, cells in a colony worked together and survived better than those alone. As the oceans grew larger and more water was spread over the planet, the number of places for life to grow increased. New chemicals from comets and from Earth's volcanoes kept arriving, making new food for cells to use. Evolution continued all the time. Each new copy of a cell could be a little bit different. Most differences did not matter, but every now and then, a change helped a cell live longer or grow faster. After even more millions of years, some cells found a way to use sunlight as food. This was a huge step for life. The first cells that could use sunlight were probably simple, but as they grew, they changed the air around them. These cells made waste that was a new gas called oxygen. At first, there was very little oxygen in the air, but as more of these sunlight-using cells filled the seas, the amount of oxygen began to grow. Oxygen changed everything on the planet. Before there was oxygen, only certain cells could survive. With oxygen, new kinds of cells formed. They could get more energy from their food and could live in new places like shallow seas, deeper water, or pools near the land. The story of oxygen in the air marks a turning point, and it led to the chance for even more complex life later. Even as bigger changes came, the simple single cells still played the most important part in the beginning of life on Earth. Every living thing today can trace its history back to these first cells, which were built from water, amino acids, sugars, carbon, and fats, all joined together in the right way. The early seas and lakes were like busy factories for chemistry, where millions of tiny bubbles formed and broke apart every day. The cells that lasted best were the ones that could fix themselves, use energy well, and copy themselves with the least mistakes. Over time, some cells collected more useful proteins and more ways to store information for the next generation. This way of storing information is special. In modern cells, information is stored in molecules called DNA and RNA. These molecules are written in a code made from sugar and special bases. Early versions of these molecules started to form in the same ponds and seas where life began. Step by step, small parts joined to make longer chains, and those chains were better at holding and sharing information. Cells with even a simple information code had a big advantage. They could pass on their best ways of living each time they made a new cell. Good features stayed and mistakes slowly got pushed out. Over many generations, this information code grew longer and the cells could do more. Eventually, some cells learned to eat other cells or tiny bubbles for food. Some learned to make hard shells to protect themselves, while others joined into loose groups that could move together. The first signs of real teamwork started, leading later to plants, animals, and all the living things seen today. But even in these later steps, the main idea did not change. Every cell still needed water to work. Every cell was built from amino acids, sugars, and other pieces first brought by comets and formed on early Earth. Every copy depended on repeating the patterns that worked best. To better understand the growth from simple chemicals to living things, scientists do laboratory tests that try to copy the steps of early life. They use water, amino acids, sugars, and fats in warm and cool places. Sometimes they create electric sparks or change the light. In these tests, they see small bubbles form. Amino acids join, sugars give energy, and chains of simple information form. Each time the steps match what is seen in the study of old rocks and comet dust. Nothing that happens in nature is instant. Every cell, every chain of amino acids, every bubble had to wait for the right moment and the right place to join together. Early Earth gave millions of chances, with each day and night, each drop of rain, and each splash of comet water. In the journey from simple molecules to living things, teamwork was always important. First, chemicals joined to build proteins and other useful parts. Next, they formed bubbles and protected themselves from the world around. Then, they found ways to copy themselves and pass on good features to the next generation. With every step, the story took a little longer, but it always moved forward. There may have been false starts, places where cells almost lived but died out quickly, or where bubbles formed and broke apart. But over enough time, the ones with the best mix of proteins, sugars, fats, and information survived and made more of themselves. The world, after the rise of these first living cells, was never the same. All around the planet, in every pond, lake, and warm seabed, cells were copying, using energy, and beginning to fill the Earth with life. Once started, life did not stop. It only grew, changed, and became more complicated. Looking far into the past, to those first ponds and seas filled with comet water and dust, it is clear that everything alive today has deep roots that go back to those first bubbles. The story of growth, from the simplest chemicals to the first real living things, does not just belong to Earth. It is a story that could happen anywhere the same steps and the same ingredients come together. That is why every new test, each small fossil in a rock, every comet sample from space is so exciting. All these clues join together into a story about how life grew from tiny pieces step by step until the first living world opened up on Earth. As life on Earth began to fill the oceans and lakes with tiny cells, the question of whether these steps could happen somewhere else became more important. The story of our planet shows that water, molecules from space, and the right conditions together made life possible. If these things joined on Earth, scientists wondered if the same could happen far away, in places no one has ever visited. When scientists look into space with strong telescopes, they see many comets moving around stars far away from the Sun. These comets are made of the same kinds of ice, dust, and simple molecules as the comets that brought important parts to Earth. They move in big orbits, sometimes close to their star, sometimes very far away. Some comets travel through their home systems for hundreds of thousands or even millions of years. Others are knocked out of their paths and fly through space for a long time, sometimes leaving their home system and traveling alone. These comets are cold and dark most of the time, but when they come close to a star, they heat up and their ice begins to turn into gas, forming a bright cloud and a long tail. When scientists measure the light from these comets, they find water, carbon, oxygen, nitrogen, and sometimes the very same molecules that were found in comets in our own solar system. Some of these molecules are amino acids, sugars, and small pieces of carbon chemicals, the same building blocks used by life on Earth. Around other stars, strong telescopes have also found clouds of gas and dust called protoplanetary disks. In these flat spinning disks, comets, planets, and smaller bodies are born. The dust and gas gather and stick together over millions of years, growing into rocks, then bigger planet-sized balls, and into planets themselves. In these places, impacts from comets are very common. When young planets are forming, the leftovers from their birth, comets and asteroids, move in big numbers through the new system. Many comets hit these new worlds, each one carrying ice, water, and special carbon molecules, just as they did on the early Earth. When scientists study the light coming from these young disks, they find some of the molecules that are the starting points of life. They see signals of water and the shadows of carbon-based molecules moving around the newborn planets. Sometimes they see changes in the disks after a comet impact, signs of new gas and dust created after a crash. Some stars have planets that look a little like Earth. These planets are called exoplanets. Telescopes can sometimes find out if these exoplanets are in the right place around their star to have water in liquid form. If the temperature is not too hot and not too cold, water can make lakes, seas, or oceans. These places are called habitable zones. If a rocky planet or moon sits inside one of these zones and gets hit by enough comets, it may gather water and other important parts needed for life to start. Scientists now know that there are billions of stars in our galaxy with planets around them. Many of these planets may have their own comets, bringing new water and chemicals. This means that the story that happened on Earth could be happening in many other places in the universe. Meteorites and small pieces of comets do not only hit Earth, they hit Mars, the Moon, and the moons of other planets too. When spacecraft look at Mars, they find signs that water once flowed on its surface. There are valleys and dry riverbeds, old lakes and minerals that only form with the help of water. Mars has also been hit by comets and asteroids for billions of years, just like Earth. Some moons of Jupiter and Saturn, like Europa and Enceladus, are covered with thick ice, but underneath, scientists believe there are big oceans of liquid water. Comet impacts into these icy moons could deliver more water, heat, and molecules from space. Space missions have found signs of simple molecules and water vapor coming out from cracks in the ice. Big clouds of gas shoot up from the moon's surface, and when they are measured, sometimes scientists find ingredients needed for life. The history of water and molecules from comets is written into the surfaces of these planets and moons. Impact craters, strange minerals, and even frozen lakes tell the story of many billions of years of comet impacts. Each new mission that sends back pictures or samples from these distant places helps people understand that comets have visited many worlds and left behind important materials. Scientists also see that comets break apart and lose small pieces as they travel. Dust and little rocks from these comets can land on other planets, adding more carbon molecules and building blocks for life. The universe is not empty. It is full of movement, dust, ice, and many chances for molecules to end up in new places. When astronomers look at the light from other solar systems, they sometimes see the marks of large impacts, big changes in the light or sudden bursts of gas and dust. These could be signs that comets or asteroids have hit a planet or a moon. Computer models show that early in the life of a solar system, it is normal for new planets to be hit often by comets. These impacts may last for hundreds of millions of years. Clouds of dust and gas around other stars can show signals of carbon molecules and water. Scientists use tools that split light into colors to find out exactly which molecules are there. In some cases, telescopes have found simple sugars, alcohols, and even amino acids flying in the clouds between stars in the Milky Way galaxy. Because comets are everywhere, and because they carry water, carbon, and amino acids to planets around many stars, scientists believe the building blocks for life are not rare or unique to Earth. The same process that helped life start here may be helping it start elsewhere in the universe. The question that comes next is whether simple molecules actually join together to make life somewhere else. Right now, scientists do not have a way to travel to other worlds and bring back living things. But they keep searching for signals that could mean life has started. This can be a change in the air of a distant world, the way its color changes with the seasons, or strange signals of chemicals that do not match anything made by rocks or water alone. When studying the planets and moons in our solar system, scientists look for three main things: water, heat, and the right molecules. When all three are present, life has a chance. Some places, like the planets close to their stars, are too hot. Others, far out, are too cold. But there are many worlds, moons, and even asteroids in the right zone to let water be liquid, and these places also get hit by comets that can bring new materials. Some scientists have even sent special spacecraft to test for these ideas. On Mars and on the moons of Jupiter and Saturn, robots and probes have looked for water, new minerals, and organic molecules. Each new test that finds these clues is a sign that the story of comets and the beginning of life could be playing out far from Earth. All over the sky, stars are born, giving off heat and light, and making new planets and comets. By looking at these young systems, astronomers can watch the story repeat. Clouds turn into disks, disks become planets and comets, impacts happen, and water and molecules move from one world to another. The story of life's ingredients being everywhere is not just about our galaxy. Other galaxies, very far away, sometimes show the same signs: water, carbon molecules, comets. The universe is old and has had many chances for comets to visit new worlds, bringing the right materials and making it possible for life to begin again and again. The possibility that life could start somewhere else has changed how people look at our own planet. Earth is now seen as only one place where the mix of water, space, and the right molecules created life. It is special, but it may not be alone. Every new discovery about comets, planets, and molecules makes the idea of life in the universe feel more possible. As research continues, scientists are always looking for new ways to test these ideas. Some plan to bring back pieces of Mars or the icy moons. Others use big telescopes to try to see planets that are far away, looking for the tiny changes that can only mean something alive is at work. There are also ideas that life could travel between planets and solar systems. If a comet or asteroid picks up tiny living things or tough molecules from one planet, it might carry them to a new world if it crashes there. This idea is called panspermia, and while there is no proof for it yet, the movement of water and molecules by comets shows it is at least possible. The most important thing learned is that the building blocks for life travel easily in the universe. Water, amino acids, sugars, and other small pieces can exist in space, hide in dust, or travel in comets for millions of years. When the right world is hit by enough comets, it may gather a new supply ready for life to start. The same story of water and molecules joining together could happen far from Earth, in the dark seas under ice on a moon, or in a warm pond on a new planet around a distant star. Each time water appears and molecules mix, the chance for life begins again, waiting for the right step. The search for signs of life in space uses many tools. Radar watches for comets, telescopes look for new planets, and spacecraft collect samples from worlds never before touched. Every mission, every study brings a little more information and a little more hope that life may be starting elsewhere, following the same steps that happened on Earth. Many scientists believe that the universe could have many places with life because the steps needed, water, energy, the right molecules, and time, are repeated over and over again. The more planets and comets exist, the more likely it is that somewhere the pattern is happening now. In the end, the story of life's building blocks in space is one of travel, connection, and new beginnings. Every comet, every planet, every ocean, and every pool of water is part of a much bigger story that goes beyond Earth. The lessons learned by looking far away help explain how life became possible here and may help people one day find the answer to whether anyone or anything is alive on other worlds. As people learn more about the history of water, comets, and life's building blocks, bigger questions start to form about where we come from and what our place is in the universe. The story of comets and the start of life on Earth changes how we think about our own beginnings. The simple idea that everything alive today may have started with materials both from Earth and from space makes many people wonder who we are and how much we share with the rest of the universe. Long ago, many people thought that life could start only from things already on Earth. They thought all the water, rock, and living things must have always come from this planet alone. Now, with so many clues from science, it is clear that Earth did not do everything by itself. The oceans, the air, the first simple cells, and even the molecules inside every living thing were helped by the arrival of comets and by the visits of stones and dust from space. This new way of thinking connects everything on Earth to the much bigger world outside. Every drop of water, every leaf, every animal, and every person holds atoms and pieces that may have traveled through space for a very long time before becoming part of life here. This connection to space does not make Earth less special, but it shows that we are part of a much larger story, one that reaches out beyond our skies. Scientists now ask if life on other planets might begin in the same way. They wonder if comets could bring water and the right mix of molecules to any world with the right conditions. If so, life might not be rare, but could start up in many places, given enough time and the right steps. This idea changes the way we look at the sky, and it changes questions about whether we are alone. For many years, people wanted to know how life could begin at all. Now, the question is changing. People wonder if life is everywhere, waiting to appear as soon as the right events take place. Comets cross the sky and travel between planets, bringing water and the building blocks for cells again and again. When we see how the ingredients for life travel across the universe, it makes us look at the story of Earth's past in a new way. Living things may have started when pieces from our planet joined with pieces from far away in a mixture that had never happened before. This mixture made something brand new. The first cells grew, learned to copy, and filled the oceans and lands. The same pattern could be happening out there on a planet we have never seen, with comets dropping water and dust onto new worlds. If comets helped make life, then every living thing on Earth is, in a way, part of both the planet and the universe. The clouds, rivers, and seas are touched by what arrived from the stars. Every green leaf and every animal has atoms that were once dust in space. People, even without knowing it, carry a piece of history that began before the Earth itself formed. When we think about the planets in our solar system and see the clues of water and chemistry in the rocks and ice, we learn that the story of life could have started on another planet, perhaps even before it started here. Maybe life was tried on Mars or the icy moons of Saturn or Jupiter, places where water and comet dust met, but where the right steps did not last. Our own story may not be the only one. New questions appear as more is learned. What if life is common? What if life's building blocks are everywhere, just waiting to join in the right way? Does life always follow the same path, or can new kinds of living things come from different mixtures of molecules? Is there somewhere today, far away, where cells are just starting to join for the first time, like they did in Earth's warm ponds so long ago? These questions are not just about science. They also make people ask about their own place in the world. If all living things come from a mixture of Earth and space, then every person, plant, and animal is connected to something very old and very far away. The story of life becomes a story that joins everything, not just on this planet, but across the whole sky. Many cultures already have stories about coming from the stars, even before science began to find clues that match this idea. Today, as telescopes get better and space probes send back new evidence, the idea that life's beginnings come from both Earth and beyond is no longer just a story. It is something people can test, study, and understand in a careful way. Understanding these big ideas changes the way people make choices. If the water in your cup was once ice from a comet, or if the carbon in your body traveled through space for billions of years, then every part of life is linked to the world and the universe together. This knowledge can bring a feeling of connection to all living things and to the planet that supports them. As scientists keep searching for more signs of comets and life's building blocks around other stars, the idea grows that there could be many other places where similar stories are happening. Maybe every day, somewhere far away, a comet is bringing water and molecules to a young planet. Perhaps, after long ages, new living things will join and begin to grow there, just like they did here. The search for the answer to "Are we alone?" becomes a search for understanding how many places in space could hold life. Will the story of living things, built from the same basic molecules, repeat in planet after planet? Or does each world need something more, something only found on Earth? Research into life's beginning helps people ask questions about what it means to be alive. What is needed for something to be called living? Is it enough to copy and use energy, or are more steps needed? Did life on Earth start from only one mix of molecules, or could it begin differently somewhere else? These questions move beyond science into ideas about who we are as living things. Because comets are so closely connected to the start of life, every new discovery about them is important. The shape of a comet, the types of ice and dust inside it, the kinds of molecules it carries, all of this helps tell the story not just of where water and life came from, but what kind of world Earth became. If comets really did bring water, amino acids, sugars, and the first important building blocks, then they are part of the story of everything alive today. Flowers in a field, animals in a forest, people in cities, and life in the sea, all are only here because the right things fell from space long ago. The comets that glow in the sky are a sign of that deep connection. The story of origins does not just help explain the past, it also points forward. If the universe is full of the same building blocks, then the story of life could start again somewhere else, if given enough time. Maybe new living things are beginning far away, on a world with water, warmth, and the special molecules that comets help provide. Understanding our origin also means understanding our responsibility. If we are part of something that began with the first comets and reached across space, taking care of our planet means more than just protecting our home. It is about respecting something very old, very rare, and deeply connected to all other things in space. Every question about where we came from helps shape how people look at each other and at other living things. If we all share the same building blocks, then life on Earth is a family, joined with the planet and with distant dust and comets that may be falling even now. People still search for final answers, looking through microscopes with spacecraft and by studying the rocks, ice, and stars. Each clue, each small discovery changes our picture of the past and gives hints about the future. If evidence one day shows that life began somewhere else in space, or if we find signs of cells and water on another planet, the story will become larger and even more connected. Even now, as new experiments test the power of comet impacts and recreate the chemistry of early Earth, people learn more with every step. Every result is checked, tested, and compared to what is found in rocks, water, and the news from space missions. Knowing that life's start is a story of both Earth and space makes every comet, every drop of water, and every living thing more interesting. It makes our planet feel both unique and also linked to a universe full of places where life could be. It helps remind everyone that the dust, ice, and water of comets are still all around us, quietly joining the circle of life with each fall from the sky. With every answer, there are always more questions, but each step brings people closer to understanding where we fit in the universe. The journey to learn how life began joins everyone, past and present, to the greatest story ever told. One that goes from the surface of Earth to the farthest stars, with comets lighting the way. As people continue to ask where life began and how the Earth and comets work together, scientists all around the world are busy searching for answers. Every year, new experiments are planned, new missions to space are sent, and new rocks, ice, and dust are found. The journey to understand life's start is still going on. This journey brings together people who study space, those who love chemistry, those who look for life, and those who study the oldest places on Earth. In special laboratories, scientists use mixtures of water, ammonia, methane, and other simple chemicals, copying what may have been found on early Earth and inside comets. These mixtures are placed in glass tubes and warmed, cooled, and sometimes even given small electric shocks to copy things like sunlight or lightning. After days or weeks, the mixtures are checked carefully. Scientists see if any new molecules have formed. Sometimes they find amino acids, sugars, and even small pieces that can join together to form bigger parts needed for life. These experiments show that the building blocks of life are not hard to make if you copy the right conditions. This is a hopeful sign that what happened on Earth could happen in other places too. Each new test makes small changes in the mix or the energy used, and the results are collected and compared to the real molecules seen in comets and meteorites. There are laboratories where people work on collisions, using strong machines to shoot small balls of ice and rock at high speeds into other materials. These collisions copy the power of comet impacts on early Earth. After the crash, scientists look at what is made by the heat and pressure. Sometimes, amino acids, small sugars, or fat-like molecules are found. These experiments are important because they show that comet impacts do not always destroy molecules. In fact, sometimes they help make more of the special parts needed for life. Space agencies from many countries build spacecraft to fly past or even land on comets and asteroids. When a spacecraft gets close, it collects dust, ice, or takes pictures. Sometimes, a small piece is brought back to Earth in a strong, protected box. When this happens, scientists open the box and search inside for special molecules. Every time they do, they find new information. Some missions found water, carbon, simple sugars, and even amino acids hiding in the dust. Robots are sent to other planets and moons to test for water and special carbon molecules. These robots drill into the ground, scoop up ice, and heat it to see what gases come out. They look for signs that liquid water was there, and for tiny pieces that could be used for life. Every time a robot finds even a little bit of organic material, it helps prove that what happened on early Earth could happen somewhere else. Telescopes in space and on Earth are always searching for the signs of comets, water, and special molecules in the sky. They study the light from stars and planets. By splitting light into many colors, they can see what kinds of things are there, even very far away. When they find water, carbon, or amino acids in another place, it is a hint that the story of life may not be just for Earth. People who study rocks, called geologists, look deep in old mountains, deserts, and ice for pieces of the past. They find meteorites that have been buried in snow for thousands of years, or that fell long ago. These stones are opened up and checked for signs of water, carbon, and amino acids. In old rocks from Earth itself, scientists search for the first marks of cells or for patterns that show tiny living things grew there billions of years ago. Every few years, discoveries are announced that change the story just a little. Sometimes, a new kind of amino acid is found inside a comet sample. Sometimes, a hidden lake is found under the ice of a planet or moon, showing where water could support life. Sometimes, changes in the light from a distant planet hint that something alive could be changing the air or using sunlight in special ways. The way scientists check these findings is slow and careful. New discoveries have to be tested again and again by different people in different labs. This is important because the story of our beginning is something that many people want to get right. When tests show the same result in more than one place or from different samples, the idea becomes stronger. There are also new ideas about how life could travel. Some people think that if life began on one planet, small pieces of it might ride on dust or inside small rocks and move to another world after a big impact. If this happened, it could mean that life does not start only once, but can spread to new places in the right conditions. Because of all this research, the view of comets has changed. In the past, comets were seen only as shining stars in the sky, sometimes bringing fear or wonder. Now, they are also seen as bringers of water, carriers of life's building blocks, and travelers from the edges of our solar system. When people see a comet in the night sky, it is a reminder that the story of life may be bigger than just the story of Earth. All of these modern discoveries help make the picture of our origin more clear. The history of oceans, the rain from space, the ponds filled by comet water, and the rise of the first cells are now studied together. With new tools and ideas, the gap between what happened billions of years ago and what we see today is getting smaller. Young people in schools are learning that comets, water, and life's building blocks are part of one big story. Teachers use pictures of comets, videos from space missions, and real pieces of meteorites to help students understand how the past and the present are linked. This helps more people see that science is not just about facts, but about finding new ways to look at the world and to ask questions that matter for everyone. Space missions are planned many years ahead. In the coming years, new probes will fly to the icy moons of Jupiter and Saturn. There, they will look for water underground, heat, and the special molecules needed for life. Others will look for new comets or try to catch dust in space. Some missions will try to land on the surfaces of Mars or other planets, drilling deeper than ever before in search of new clues. International teams work together on these missions. Countries share information, tools, and ideas. By working together, everyone can use the best technology and the best minds to answer the biggest questions. This teamwork is a new way that the search for life brings people together, just as comets long ago brought together water and molecules to form life. In research centers, computer models are used to see how water, impacts, and molecules could mix on new planets. These virtual tests help scientists guess what to look for on other worlds and where the best chances for life may be found. Some models show that with enough comet impacts, almost every planet in the right place around a star could have water and all the building blocks needed in the past. New experiments also test what happens under high pressure, deep inside planets, or at the bottom of icy oceans. By copying these hard places, scientists hope to find out how molecules could join together and even how life could hide in places without sunlight, but with warmth from inside a planet. There are many questions left to answer. No one knows if there is life on Mars, under the ice of Europa, or in the clouds of Venus. No one knows if a comet has soft pockets where small cells could live quietly, waiting for a new home to land on. Each new test, each new mission is another chance to learn something new and to bring one more piece to the story. People also wonder what will happen in the far future. Will comets keep bringing water to new planets for as long as there are stars in the sky? Will humans one day travel to these new places and look for life with their own eyes? Will the story of comets and their gifts help people take better care of Earth by understanding how rare and special our planet is? The science of comets and the search for the beginning of life do not only help explain the past, they make people think about the future, about caring for the planet that grew from so many small gifts, keeping it safe for all life, plants, animals, and people. Every answer leads to new questions. Scientists collect, test, and share what they find, making a record for those who come after. Children who see a comet today may be the ones who make the next big discovery. Each new piece of dust, each new drop of water, each new signal from space adds to the story. In every part of the world, people look up at the stars and wonder. Some hope for answers about life elsewhere. Some try to understand how we began and how we fit into the universe. Others look to comets and space to guide their hopes and dreams for the future. The journey of discovery is not finished. The work goes on, in labs and with telescopes, with space probes and with students asking questions. All of this helps build a better picture of how Earth and comets made life possible and why that story matters so much for everyone alive today. With each year, the understanding of how comets and Earth work together to start life becomes more clear. Experiments, space missions, computer models, and the study of rocks, ice, and water all help add new knowledge. As new answers appear, they help people see not only where life began, but also what can happen when many small things join together for a long time. This search is a journey that belongs to everyone. The story of life's beginning with comets, water, and molecules continues to grow as people learn, test, and dream. The next time you see a comet shining in the sky, Remember that it may be more than just a visitor from space. It is a part of the story of how everything alive on Earth began and how all life is tied together with the rest of the universe.